All right, so homework assignment there. Since this is stuff that we've already done, ordinarily I would have made this due next Tuesday, but we don't have class next Tuesday since it's advising day. It's Tuesday's advising day, yeah, already. So, yeah. So we will have class next Tuesday, which is why that's due on Thursday. So, plan for this week, pardon me, is today we're going to finish up getting code written up to calculate cubic splines. And then we're also going to spend a little bit of time today talking about how we can graph parametric equations, which seems a little bit off topic, but the idea behind that is that you're going to combine the two things. Combine the two things into your next major assignment, which I'm going to assign on Thursday. So that you'll have no class on Tuesday, so you'll have time to work on it. So that's the plan. All right. So, any questions at all over anything before we get started? As far as the homework goes, the first problem would have been the stuff that we talked about. I think it was before break, actually. The second problem was one like what we did last time, and then the third one involves using the Excel spreadsheet that we set up for splines. So all that stuff we've covered, so hopefully it won't be horribly onerous to figure out how to do it. I'm not giving you a week and a half to do it because I think it's long. I'm giving you a week and a half because we got no class next Tuesday. So otherwise I would have had to do it on Tuesday. So in any event, let's continue on then with where we left off last time, where we started trying to write down, at least by hand, some code to create, to figure out our cubic spline functions. So the idea here is going to convert what we already know how to solve, the system that we come up with for trying to calculate the coefficients for our cubic splines, so then we can have our not only evaluate if you wanted to, but in particular being able to graph these things so that we see what the plot looks like. So that's our goal, is hopefully to get to the point where we can calculate our coefficients and then show how we can plot these things. And then, like I said, in the class, we are going to switch gears a little bit, but it'll be related to what I want you to do for your major assignment, and that'll be graphing parametric equations. So that is today's plan. So last time we started off by saying, if we're going to make a cubic spline that interpolates a set of points, then we probably should pass in some x's and some y's that we want to be able to do that, right? And after we pass in those points, we probably want to figure out what our deltas are, because our entire system of equations is built on the deltas. And our formulas for figuring out the x coefficients and the x cubed coefficients are based on the x squared coefficients and the deltas. So we'll need those deltas as well as the x squared coefficients, what we call the c's, to be able to figure out the other ones, right? So that's our goal today. So let's think about what's going on with this particular idea. So if we think about what we did in Excel, we did the kind of the forward solving and then did the reverse substitution, the back substitution stuff to figure out the C's. So let's see if we can figure out how we would need to program that. So let me switch pages over here just so that we can remind ourselves what the system looks like and then what the computation processes are, so that we need to figure out what we need to actually store. Okay? Try to be as efficient as possible. All right, so remember that when we make our matrix, and we're only going to do natural cubic splines. I mentioned that there are other types of cubic splines that we could do. We're only going to worry about the natural cubic splines one. So remember that we assume that the first coefficient, the first C, is 0. And then we use that dummy one, of the last one is 0, so that we can get an exact solution, right? So our original system, if you will, has a 1 on the upper left-hand corner. And then, of course, let me spread this out a little bit. so that we actually see it. And then the next one had what? A delta 1, a 2 delta 1 plus 2 delta 2, a delta 2. And then I'll put an extra 0 in here so we can see it. 0's here, right? Then it shifted over 1. This is delta 2, 2 delta 2 plus 2 delta 3, delta 3, and so on down the line, right? We know the very, very last row had a bunch of zeros and then a 1. But right before that, and I don't have the columns in here, but right before that, this was what? Delta n minus 1 here. This was 2 delta n minus 2 plus 2 delta n minus 1. And a delta n minus 1 here. Or, sorry, n minus 2 here. You're welcome. That was what the system looked like. Now again, remember that we also had a right-hand side of the equation. Remember though, this first row we could use to eliminate this delta 1, and it doesn't change anything else in that row, right? And in this last row, we could use this 1 to delete off that, if you will, eliminate that delta n minus 1, and it doesn't change anything off in that previous row, right? So we're going to write that here in a second. But since we're assuming that we have a natural cubic spline, those C values are also 0. So when we look at the constants as well, we would have a 0 as our first constant, a 0 as our last constant, and the elimination that we do here and here also wouldn't change the constants on the other side, right? So I don't need to worry. I know that the values for C are 0, the C1 and the Cn are 0, and they don't change into the other values. So I don't need to worry about storing those because I know what they are, right? Okay. All right, so once we do that, what we're interested in doing, of course, is how do we get the rest of this? Well, we already have, when we wrote down, let me just go back real quick. When we started off doing some kind of, I'll call it pseudo code, because I'm just trying to write down the functions as we go along and not worrying about the pseudo code part. Notice that we've already calculated the deltas and the deltas for the x and the deltas for the y, right? So I don't need to restore them again. I already have them. Okay. But let's go back over to the system and see what's happening. Remember again, our elimination process. Let's see if I can. Well, what in the world am I doing? Just trying to change the color of my pen, and I was not having much luck. All right. Remember our elimination process here. We're already eliminated. We're going to be eliminating that column or that row out, right? And this column, and that row, and that column, right? We've already got rid of all of those things. All right, so when we're going through that elimination process, remember again, we already have this delta stored here. We would have the delta 3 here. That would be stored as well, right? And those are the ones that we're trying to get rid of, isn't it? When we get rid of it, if we think about, did I change the color back easily? When we get rid of it, notice the first one's still going to be a 2 delta 1 plus a 2 delta 2 here, right? And a delta 2 here. Yeah. So I'm trying to think about what I need to keep track of, and in particular, I'll need that coefficient for our back substitution process, right? All right. Now, when we get rid of this delta 2 here, this now becomes a 0. It goes away. I don't need to keep track of it at all. It's gone, right? You agree with that? Okay. This, however, does change. This number here, right? what does it change to? So I agree with that part. Remember, I'm going to work off of here to get down to here, right? So it'll be what? It'll be a minus that delta 2. So there'll be I got to work off of this, right? So it'll be times the delta 2 over 2 delta 1 plus 2 delta 2, right? Yeah. That's where that comes from. We're not going to use all of this particular formula, but that's okay. Or it just says where it comes from, right? I've got to make this a 0. That delta 2 is 0. So I've got to multiply that coefficient right above it by the opposite of delta 2, because I want to add down and make it 0. But I can't just multiply by the opposite of delta 2 because then it's too big. I got to divide out by whatever that number is there, correct? So this is what it would look like if I were to write it out, right? Yeah. Okay. Whatever that number is, notice that right below it, notice we got rid of this one. That means now this 0, right? Whatever that happens to be. This now has changed to whatever it is. Doesn't matter what the number is, it's changed, right? Does this number change in that step? No. So this is still a delta 3 here, right? We agree? Okay. I know I wrote out this big long formula. The coefficient's important, but the formula isn't. Because now this is just some number. I'll call it n, whatever that happens to be. Right? Okay. Notice right below it, what are we going to have right below it? Below this one? No, so remember, we got a 0 here because it was here, right? This is going to be delta 3 is the next one down below it, right? And then we're going to have 2 delta 3 plus 2 delta 4 here. And delta 4 here, aren't we? Now, we're making these delta 0 and we're changing the main diagonal, but does this upper diagonal, this top diagonal, does it ever change? No, so there's no reason to keep track of it at this stage, right? So the only thing we have to keep track of is what? That middle diagonal thing, right? So we just need to make a list of what's going on down the diagonal, right? Okay, so let's think about what's going on down the diagonal in terms of a formula so that we can actually write that down, pardon me, as a function, not a function, but as an operation that we're going to be doing in our code, okay? So I'm going to create basically a list of things. What's going to be the first thing in my list? The 2 delta 1 plus the 2 delta 2, right? You agree with that? Okay. That'll be the first thing in our list. I'm going to write the code here in a second, but the first thing in our list is the 2 delta 1 plus 2 delta 2, right? That's going to be item number 1. How do we get the next one in the list? So let's say, I'm going to think about it, this is a list. This is item number 1 here, right? Okay. I've also got a list of deltas that are going delta 1, delta 2, delta 3, and so on down the line, right? How do we get the next one in my list? What are we doing? It is where the n is, right here, correct? Okay. But notice that once we do this n, we're going to use it to get to the next one, correct? So if I call this, I'm just going to call it what? I'll call it L for my list, right? So if this is L1, to get this one here, we did what? We did 2 delta 2 plus 2 delta 3. That was this part, right? Minus the delta 2 times the delta 2 over whatever the previous element was in the list. Right? Whatever that happens to be. Okay, so notice what the format looks like. Look at I'm thinking about the indices as we go along here, right? Because I want to try to do this with a for loop as I'm going through, right? I want to iterate through. This second element here is referring to the second and the third of the deltas, right? This one refers to the second of the deltas. This is the previous one in the list that we're in, right? So if we call this one L2, say this is, this is part 2. So let's just refer to this as L2. The next one over would be what? What would the corresponding part be for this part? Good. Yep, and then minus delta 3 times L2. Yeah. Right? Agree? And we would keep doing that how many times? Minus 1 times, right? You agree with that? Okay. Or whatever the length of the list is, minus 1 times. All right. Or how many ever deltas we have. Yeah? Okay. So if we go back over and see if we can code that up. And then we'll also need to keep track of the y's. So we're going to have 2 things in our for loop here in a second. Okay. Oops. Oh, heavens. We're going to have our for loop. Oh, I need to initialize something too. I need to put something in up here. We'll have our for loop go from the first element, or I guess it's going to be the. I'll figure it out here a second. Make sure we start this and end it in the right spot, right? Because notice that, I'll go back over to the other sheet in a second. But notice again that with the last delta that we're actually referencing is an n-1 delta, right? I don't actually get all the way to the end of my list. Okay. All right. So I probably need to initialize a couple of things. I haven't done that yet. So I'm going to leave a little bit of a space here. Grab this and move it down. We need to keep track of those intermediate numbers, whatever they happen to be. So I'm just going to give it a name of answer 1, say. Just, it doesn't matter what I call it. I just need to keep track of it, right? The first one, again, is 2 times delta x of 1. I guess it's brackets. Plus 2 times, I keep wanting to write determinant, delta x of 2, right? Yeah? Okay. All right. I want to append some stuff on here, don't I? I want to keep adding to this list because that's the thing I need to keep track of. This is the diagonal part that we need to keep track of, right? Bless you. Okay. So let's go back over to what we started writing over here. Notice it's the next one in my list, right? This one here. Right? Okay. And then minus the delta of that particular whatever index we're on. I guess it's the previous index, isn't it? Right? Because we're doing, back over. Depends on where I started this. We want to make sure our indices are correct, right? So the first one, let me write it on the board so I don't keep flipping back and forth. We had 2 delta 1 plus 2 delta 2 and a delta 2, and then right below it is a delta 2, correct? And then a 2 delta 2 plus 2 delta 3, right? Yeah? Okay. So for my for loop, depending on where you want to think about starting it, I just need to be careful with where my indices go, right? And I want to make sure my indices are correct. Right? So if I use an index from 1 to 1 minus the length of the delta, what should my indices be here for my delta values? Oops. I don't know why in the world I can't write delta. Yeah, so if I'm using I for my index here and I want delta 2, then I need to use I plus 1 here and plus 2 there, right? May need to adjust where we end that. It just depends on what's going on with what we have here. Gotta be a little bit careful. Okay. And then what do we subtract off again? Okay. Delta x of I plus 1, right? The next one in the list. Times, I could probably just square it, right? Because it's the same value that we're using. And then divide it by what? Yeah, so yeah, we want to keep moving this along in the list, right? So I'm going to do the answer 1 of the I, right? Because we're going to grab the one that we're on and then add a new one, right? We're going to take the one that's right below it. Remember that this is what we're calling answer 1, right? Of 1, right? So when I get to this one, I'm going to do this over that, take the opposite of it, multiply it by that, and add down. Yes.
Is answer 1 to be a function here or a definition?
Answer 1 is it's a list. So it's the first element in the list.
Oh, okay.
Yeah. So it's whatever the ith entry in the list is. So far, so good? Now I do need to be a little bit careful. I have this to length of delta minus 1, but we've got something in terms of delta of I plus 2, right? So I probably need to go to length of minus 2, don't I? Because if I go to length minus 1, it's going to get out of the range here, isn't it? Okay. All right. So probably should change that to a 2. Good news is that we'll run this and check it and see if we're right. May have to make some tweaks. That's why I'm doing it on paper first. Paper. Just trying to, sketch out what it needs to look like as we're going through it. For some of you, that might be this might be a little bit more drawn out than you need it to be, but just make sure that we're all on the same page and starting from the same place. Like I said, you're going to need to modify what we're doing to do your major assignment. All right. Not only do I need to keep track of these, what else do we need to keep track of? What didn't we write down back on the other page that I had open? I wrote down the matrix on the left-hand side of the equation, but I didn't write down the constants, right? So remember on the other side of this equation that we had over here, back up here, remember on this other side, we had I'm not going to put down, I'll write it so I make sure that we're all on the same page here. A 0 here and a 0 there, and then it was 3 times ratios of consecutive deltas, right? So delta 2, capital delta 2 over little delta 2, and then minus capital delta 1 over little delta 1, and so on down the line. Bless you. Right? Okay. So going back over here again, we'll need to initialize capital. Well, I used delta y, didn't I? That first constant, because we're doing elimination here. We're doing the elimination here. It's going to be on both sides of the equation, so I've got to keep track of how those constants are changing too, right? Agree? Yeah. Okay. So notice we're going to do the same thing on the right-hand side over here as we did on the left-hand side. So over here we have a 3 delta 2 over delta 2 minus delta 1 over delta 1 here. And here you've got a 3 delta 3 over delta 3 minus delta 2 over delta 2 here, correct? That would be right below it to start with. But you use the exact same multiplier. Bless you. Something going around. People keep sneezing. We use the same multiplier, don't we, all the way across? So nothing changes there. The only thing that's going to change is that we're going to work off of this one and subtract off the multiplier times that thing, correct? Right? So when we go for our answer 2 here, this will be 3 times delta of y. Well, we're at step 1. This is referring to steps 3 and 2, isn't it? Just like the previous one did. So I'll have I plus 2 on the first one, and I plus 1 on the second one. That's a y. That's a 1. I don't know why I wrote a 2. Oops. Parenthesis. And then I've got to subtract off the exact same multiplier we had here, correct? This is getting multiplied all the way across that row. So what we have right here is the same thing that's going to be here. So this will be delta sub x of I plus 1 squared, and then divided by answer 1 of I. It's the same multiplier all the way across. We just have to keep track of 2 different numbers. This is the number that's right below the previous answer, this is the number that's over in the constants. Right? This is, so we got two different numbers we have to keep track of. Oh, it is the first Tuesday of the month. With the weather that's been going on, I'm like, oh, crap. So the number that's right below that we're trying to get rid of is this one, right? Here. And then we move it. So I'll get this over that is where this part is coming from here. But it's changing this one, right? So I use the new one as my new multiplier. But on the right-hand side of the equation, everything looks like this thing. It's this. It's on the right-hand side. It's this one that I'm not getting rid of it. I'm just working off of it. So it's going to change it each time. But it's the same exact multiplier because we're going straight across the equation each time. So this one is working off the one that's right directly below it that you're trying to eliminate. This is just keeping track of the constants that are on the other side. Does that help? Okay. Cool. All right. When we're done with all of this, hopefully we should get to a point where we see right on here. Hopefully, when we get through all of this, we should get to a point where we see what? Well, you should see, using what we just had, we refer to this as answer 1 of 1 is here, correct? And then I should have answer 2 of 1 here, right? All the way down to how many other things we have. Oops, that should be answer 1. 2. I wrote my things backward. I think it's n minus 1 by the time we're done here. Okay. These are still your deltas, right? This is still delta 2. This is still delta 3, right? This will be delta, should be what? N minus 1 there? Or, yeah, it should be n minus 1 there. All right, all the way down. Everything else should be zeros at that point. Assuming we've got all of our computations done correctly, that's what we should have in our lists, right? Okay. On the right-hand side, we should have a list that looks like answer 2 of 1, answer 2 of 2, answer 2 of n minus 1, all the way down, right? That's what we should have, correct? Hopefully. We did everything all right. Yeah. Okay. So now we work backward, right? I'm going to need to work off of here to get this answer. This is what we talked about last time, especially when we set up our spreadsheet, right? I need to work off here to get my last C, right? And then from there, I plug that in to get my next C up, correct? And keep working our way back up the line, right? So how are we going to accomplish that? Apparently we're going to accomplish it quietly. Okay, let's think about it this way. If we start with, let's say we start with initializing some list, because this should be where we're getting our list of C values at this point, right? Yeah. Okay. So at this point, remember we also have those dummy values that are in there, but it doesn't really matter. We should be able to get our list of C values here. Let's just initialize it to, just let's be blank to start with. Start there. Well, actually, let's not start it to be blank. What's going to be the first one that you're going to put in your list? So which of the C's are you going to solve for first? So remember again, you've got the C1, the Cn in here, right? Which of those are you going to solve for first? You're going to solve for the Cn minus 1, but yeah, the Cn minus 1 is the one we're going to solve for first, correct? How are you going to find it? What are you going to do?
We need to get the constants and divide it by the middle bottom part of the equation.
This part? And this part? Is that what you told me?
I'm checking on
What's the very last row? What's the equation is the very last row telling you? Bless you. Yeah. This coefficient times the Cn minus 1 is equal to the constant. How do I solve for Cn minus 1? Just divide it, right? I just need to divide it across, don't we? Okay. So if I go back over here, we should be able to initialize this to answer 2 divided by answer 1. I just need an index, right? Well, so we should have all the answers just in their answer list, right? So I probably want to use the length of the answer list, right? Okay. So in here, we would use length of answer. It doesn't matter if it's 1 or, if you've done this correctly, they both should have the same number, right? So that should be length of answer 2. You can put a length of answer 1 here. It should just, it was the subtracting the 1 should already be baked into the list length of the list. It should be 1. That length should the length of that list should be 1 less than the number of the delta that you have already. Okay. Yeah. Or 1 less than the number of points, I guess I should say. That would be the first one we need, right? How do we work back up the list? Yeah, like,
Why are we solving for n minus 1 first?
because we're going to do the back substitution up,
Oh,
right?
okay,
Yeah. We're going back substitution up the line. Yep. From there, do a for loop as well. I'm trying to remember, because we need to go in reverse, right? Yeah. Okay. So probably the easiest. Well, there's a couple. I think you can actually tell R to do it in reverse. Okay. So let's think about how we need to go, and then we'll just do it that way. We can adjust it ourselves to figure out how to do it in reverse. Anyway, I'm going to write on the board again so I don't have to keep flipping back and forth.
Yeah, or you could append the list onto the function instead. As it.
like making a enhanced for loop.
No, I'm pretty sure R will just let you append
You can put the element first and then the list on the end, right? I think we'll do it.
I think so.
Yeah. You can also use just C of, and it'll do the same thing as the append command does. Okay. All right. So, what's that?
We were talking about different things.
Oh. The one above this, the equation is what? It is whatever the previous term is in the list times Cn minus 2, right? That's the previous one on the list. And then plus, this is still a delta, isn't it? Yeah. I'm not 100% sure about that particular number. That's okay. Well, like I said, we may have to adjust this and make sure that we're all on the same. We're all got this right. This should be the then minus second one on that list. Yeah. Agree with that? Okay. All right. We know what the previous C value is, don't we? Yeah. Well, how do we figure out what Cn minus 2 is? What do we need to do? Good, exactly right. I need to plug in what this is, right? I need to multiply it by whatever the appropriate delta is. And like I said, we need to make sure we have the right index here. Whatever the appropriate delta is here, right? Agreed? Right? Whatever this is, subtract it over and then divide by this answer coefficient that we have here. Right? Is we're going through? Okay. So let's make sure we have the right delta before we keep going. Remember over here, all the way up here, this was delta n minus 1 on this last one, but it got eliminated, didn't it? I think this one right above it is delta n minus 2, isn't it? I don't think it's n minus 1. I think it's n minus 2 here. Okay, so in this one over here, we'll need to make sure that we have everything done correctly. So, but I want to make sure I also append these on the front, right? I don't want to append them on the back. You can. There's also a reverser list command in R, if just REV of the list. So if you do them in reverse, you can just reverse it. Okay. But probably the easy way to do it, I think you can use the append command, but if you don't like to type all that syntax, you can use the C command as well. We need to do our constant, whoops, let me put parentheses. We need to put our constant. I need to know what the index is, because I haven't figured out what to put my for loop yet either, right? And then minus, I always want to write determinant. Need to figure this out too, okay? Times our previous C value, so we'll need to figure out what to put in here as well. And then divided by the answer 1 of an index, whatever that happens to be. We'll figure that out in a second. And I'm going to append that, so put a comma, and then I'll just put C values on the end, and it'll stick it on the front instead of on the back. That's the syntax we need though, right? We're going to plug in the previous C value, multiply it by the appropriate delta value, subtract it off the computed constant, and divide by that answer 1, right? So far, so good? I've got to do that the entire length of my answer list, but I've already taken care of the first case, haven't I? This was the first case. So my for loop, I'm going to start it at 1, and I'm going to go to the length of one of my answer lists, doesn't matter which, minus 1. Now I just got to figure out how to index appropriately, right? So when this is 1, I really want it to be that, don't I? When it's 1, I really want it to be the next one back, correct? If this n minus 1 is representing the length of your list, right? So I really want, when I'm referencing 1, I really want it to be 1 previous, don't I? Okay. So this one here, in here, you should be able to use, I didn't leave myself enough space. I should be able to use the length of your answer list minus whatever the index is. Right? We agree? Okay. That should also go, well, that won't go here because we only have, oh, I do have to be a little bit careful there, don't I? I want to change, might want to just reverse it now that I'm thinking about it. What do I need to do now? I need to think about what the index is on the C values that we need. This one is also going to be the length of your answer list minus I here. So that should do it in the reverse order, right? Start at the last one and end at the first one. What's this one need to be? So it's the deltas. The deltas are also going in reverse order. They're just up by. This is the delta n minus 2, isn't it? Not a delta n minus 1 we decided? So I believe this is the same one. I think this is length of answer 1 minus I as well, because it'll be shifting up as we go. Right? How about this one? I think we can figure out how to do this one. The way we have this command written, where is that value going to get put in the list? At the start of it, right? What number in the list do you want to use when you go backward up the list every time now? So the first thing we did was, the first thing we put on the list was the Cn minus 1 value, whatever that happened to be, right? The next one's going to be on the list is going to be going this way, Cn minus 2. Where do I use the Cn minus 2 to do? What do I use that number for? The Cn minus 3, where's it going to go? In front. So what's the index of the number that we need to use every single time?
Just a question on R. Does it count as an entry before it's calculated?
What do you mean? Is it going to count this as on my list before I?
Yes. Is it going to count?
No, it'll use the previous one before it does it.
Okay.
Yeah.
Then 1.
Just 1. Yep. Great. I agree. Yep. This should just be a 1 because it's going to push it on the front of the list every single time. If you're familiar with stacks, be pushing these things on a stack is essentially what you're doing. If you're not familiar with stacks, you can ignore what I said. But that's what we're doing, right? We're treating it like a stack, right? We're pushing it onto the front of the stack. And every single time I want to use the thing that's on the front of the stack to do the calculation. So again, if you're familiar with stacks, typically you have a peek command that says peek at what the top element of the stack is. This would be a peek, right? I'd peek and use the peek value and then push it onto the stack afterward, rather than pop it off the stack and put it back on again. You can, but I don't want to pop it off the stack. I want to leave it on. I still want that value on the stack. So I wouldn't want to pop. I don't want to peek. All right. That was the hard part. The rest of it should be fairly straightforward. Because once we have the C's, we know how to calculate the B's and the D's, right? That was the hard part, I think. Felt like the hard part. Did it feel like the hard part? Yes, it did. Okay, good. It felt like the hard part. All right. All right, so let's think about what else we need to do to calculate these. So remember, our formulas for your B's and your D's are what? Your D's were, what was it, C sub I plus 1 minus C sub I over 3 delta I? Is that right? I'm doing it from memory. Is that 3? Yes? Okay. Your B's were harder. Good. Okay. Right? So from the C's, the B's and the D's should be relatively straightforward to get. Right? Should be relatively straightforward, I hope. I need to run through, but remember also though, when we calculate our C's, remember we have the first value, the first C value is what always? 0. And then we use the dummy value of the last one being 0 as well, because the formula goes up to an I plus 1 that we don't actually need, correct? Okay. So, let's, after we calculate our C values, let's push a 0 on the front and push a 0 on the back. We can do that with that command. Make the very, very first C value a 0. Make the very, very last C value a 0. Yeah? Okay. And then we should be able to calculate, hopefully, calculate the B's and the D's at the same time. I don't need an extra, I got an extra parenthesis in there. Oh, I always forget to do that. Forget to initialize my lists. Sorry about that. There's not really a comma in between those two. Those need to be stuck in there as extra lines. All right. What needs to go for B values in here? Okay.
minus delta x of I over 3. Times 2 times C of 1 plus C of 2.
Okay.
Or, yeah,
I plus 1, and then plus, or C of I plus C of I plus 1, right? This is just the formula, correct? Once we have this set up this way, that is the formula. So I just need to just convert it over to code, right? The ith b value is the ith ratio of deltas minus the ith delta x over 3 times the 2ci plus ci plus 1. That's just a matter of getting the code written up for what we have for the formula, right? And the same thing for the d's, correct? That was our formula for the d values, so we would have c values of I plus 1 minus the c values of I divided by 3 times delta x of I. Oops, delta x of I. And that should give you your b's and your d's at the same time, right? You agree with that? Yep. Okay. That was a long-winded way to get there, but we got there eventually. Okay. So we also want to be able to, hopefully, be able to plot these things. Now remember, when we plot these things, pardon me. As we plot them as functions, we can do that pretty straightforwardly with R and just use that add the curve command. So we'll do that here in a second. But anyway, we need to get this coded up so we got the process going. So let's see. Let's see, do I have an example that's easy to do? That we can check our answers easily here. Well, tell you what, why don't we see here. Anyway, do I want to take all the time to type this up right now? I don't think I do. I'm thinking about it. Tell you what, why don't you see if you can get that coded up and then see if you can just print off the coefficients, and then we'll talk about how we can plot it next time. Because I also want to talk about how we want to do parametric plotting today as well, and I've only got about 15 minutes, so I want to do that as well, and then we can tie the two together on Thursday. So one of the things I want you to work on for Thursday, see if you can get that coded up, and see if you can get it to just print out the coefficients that you need. Okay, so print out the watt, so remember that the format you should be getting should look like whatever your y value is for the I, and then you should have the b sub I should be the coefficient on your x minus x sub I. Your c sub I should be your coefficient on the x minus x sub I squared. Your d sub I should be the one on x sub I, x minus x sub I, cubed. That's what we're getting, right? So just add in something where you can print off the coefficients so you can see what they look like. Make sure that we're all on the same page getting the same answers, right? Do all working code that makes sense before you try to modify it for later, right? Okay. So get that coded up, see if it's working. We already have the Excel sheet working, correct? We should have the Excel sheet working. So you should be able to use the same points in Excel, type them into R, and see if your code's matching those numbers, because you should get the same value. Okay. So that's what I want you to work on for Thursday, to get that coded up. Pardon me. And see if you can get it to work. Because like I said, I want us to all be on the same page when we do that. All right. But one of the things that I'm going to want you to do when you are working on your major assignment is that we're going to also be working with some parametric equations. That's one of the modifications that we're going to make. So I want to talk a little bit about how we can graph parametric equations because it's not built into R. Okay? So it's not too bad of a process. We just have to be a little bit clever about it. So remember that. Hopefully you remember that. You can do parametric equations for a circle. Or if you remember polar coordinates, this is kind of your conversions for polar, right? If you want a circle of radius r, I can just change the parameter theta, and it'll draw the circle out, right? If I let my x equal that and my y equal that, okay? Notice that for parametric equations, we have x and y as a function of a third variable. So to be able to plot a set of parametric equations, I need to pick values for the parameter, plug them in, and get out x and y coordinates, and then plot the points. Okay? And if you think about what your calculator or your computer does, that's all it does, right? It calculates a bunch of points and place, connect the dots. That's exactly how we're going to approach this for parametric plotting. Okay? So the way we want to do this is the following. Does anybody remember how long it takes for this to start to draw out the entire circle? What interval for the thetas you need to draw out the entire circle? What did you say, Dan?
2 pi, right?
It's just 2 pi, right? Because it'll start repeating after 2 pi. Right? Okay. So if I want to make a set of points that gives me a 2 pi interval, I don't want to go all the way back up here. You can do the following, and it's actually pretty straightforward. So if you say you just want to make a list of points, let's say I want to make a list of 1,000 points, I can just do 1:1,000, and that will make me a list of 1,000 points. That's what I have, right? Now, there's nothing special about 1,000. I just started there. I could make 100. I could make 10,000. Doesn't matter. Okay? So there is a list of 1,000 things. Easy to do, right? The syntax was that straightforward, correct? But if I want to draw the circle, I don't want 1,000. I don't want to go from 1 to 1,000. I want to get 1,000 points that are the interval from 0 to 2 pi, right? I want to generate 1,000 points to plug in here and play connect the dots, right? That's what I want to do, okay? So what I need to do is I need to scale this to a 2 pi interval, which is not too hard to do, right? There's 1,000 points, and I want them to go from 0 to 2 pi. If you want to do this for any interval at all, this is a general idea that you can do this. Make whatever you're calling your list of points, well, I'm just calling it T list because I'm thinking about plugging in T's and getting out X's and Y's, right? You have a starting value that you want, plus make your sequence of points go from 1 to how many ever points you want. I did 1 to 1,000 in this case, right? To scale this now, I'll multiply this by the length of your interval, end minus the start, and then divide by how many points you have. That will scale everything from an interval from, say, A to B. Okay? So in this case, I want to go from 0 to 2 pi to draw out my circle, right? That's what we said we wanted to do. Yeah? Okay? So to do my T list in this case, well, the starting value then would be 0, so I don't need to add anything. I'll do 1 to 1,000. Oops. I'll multiply it by 2 pi over 1,000, which is the same thing as multiplying by pi over 500. Oops, I don't need the parentheses. I was thinking Excel, sorry. Now if I look at my list of t's, I don't see the 0, but I definitely see 2 pi towards the end, right? 6.28. So this gives me a list of consecutive values from 0 to 2 pi. If you do this command, this will give you a list of consecutive of how many ever values that you want from a starting point to an ending point. Yes.
Weird question.
Mhm.
Why does it not only multiply the last number by the number 5?
Because this creates a list, so if I have a list and I hit the multiply, it runs the multiplication all the way through there. Yeah. It treats it as a list, so if I do a multiply a constant times a list, it'll just run the whole constant through. That's just how the R works there. Okay. All right. So what do I want to do with each of these? Well, I want to plug the points into my x's and my y's and get a list of x's and a list of y's, right? So let's make an x function. And let's say I want to construct a circle of radius 2. So I'll make my 2. I'll make my r value 2. And I'm just going to, whatever the function is, I'm going to return 2 times the cosine of the input. I've got a capital X there. No, I don't. Okay. This looks like a capital where I was. Do the same thing for the y. I'm making them both functions of x. It doesn't matter. I'm just giving it a parameter to pass in. Okay. To create the list of x values that you want, I'll just call it x's, x's. I just need to apply the f function to the list of t's we just generated. That's literally what the command is, right? Okay. Do the same thing for the y's.
Mine saying there's an unexpected symbol in the f(x), or yeah, f_x is equal to fx. That'll do it.
That'll do it. All right. So just to show you what we created here, here's the x list. Just to give you a list of x values. Right? Here's a whole list of them. There's 1,000 of them, right? You can see here they start at 2, they go negative, and then they come back out and they end at 2, right? Which is what you would expect, right? If you're doing a circle. Okay, go around. Okay, all right. Here's how we can plot these. I've got a list of x's and a list of y's. I want to plot the points and play connect the dots. Well, I could use the plot. The plot command works, but this is not what I want you to do. But this is what you could do. If I do the plot command and then tell it to make sure that I go from -2 to 2. Oops. Why are you not? No. And then set my limits here, -2 to 2. It should. It's because my got this zoomed in this way. There you go. It looks ugly because it's squished.
Is that really the reason?
Yeah, that was really the reason. I had it smashed all the way over so it wouldn't plot it. Yeah, that was really the reason. I discovered that the other day. That was really the reason. This is just a bunch of plots that the points that it plotted and made the circle. That's not very pretty, right? The whole point of this is that I want you to do eventually cubic splines. You'll have a set of points and then see a curve that goes through it. To make it a little bit prettier, we can use a different command. So let me do something that looks kind of goofy. Oops. All right. All I did oops. Sorry. Lots of oops. There we go. All I did with this particular command was tell it to plot the point 0, 0, but not actually plot the point. That's what the type equals n. The type equals n means don't plot the points. Okay. So I said use x of 0, y of 0, but I just created a window. Okay. I know it was goofy, but that just creates a window that has -2 to 2 for my limits. Now, what I can make a nice looking curve is I can use what's referred to as the lines command in R. This command requires a plot already opened. It's going to superimpose the graph on top of whatever is already open. That's why I had to do that first command first. But now it makes a nice smooth. It did it with 1,000 lines, but it made it. It took all the points, plotted them, and played connect the dots. So it made a nice smooth curve there. Now that we have this, we can change to other types of functions. So let's say we had something like our function was, let's say we had our x was cosine of 5t and our y was sine of 2, sine of 2t. Oops. So say that our parametric equations were x equals cosine of 5t, y equals sine of 2t. And then I want to plot this. So I'll make my new list of x's. Make my new list of y's. Make a fresh plot. And connect the dots. And there's a nice parametric graph of that. It's pretty fun. Once we have it set up, once you know how to create the list of t's, you can change your x's and y functions to whatever you want them to be, and then plot it. Just make sure you have a list of t's that gives you a nice complete set of what's going on. Okay. So you should be able to write a function where you can just pass it an f function, a y function, in a range of t values, and you should be able to spit out a new graph depending on what you have. We'll play with this a little bit more next time. Like I said, I want to make sure I went through this so that we could see what parametric graphing looks like. Because like I said, your major assignment's going to involve that. So for Thursday, make sure you go get that coded up for the splines and see if your answers that come out of the splines code matches what you're getting out of your spreadsheet. Because our spreadsheet should be set up correctly. We fixed all that stuff, right? Spreadsheet should be set up correctly. So see if you can get the code to match what you're getting for the spreadsheet. Okay? Because we need to work off that to be able to do what I want you to do for the major assignment. All right? Have a good one. We'll see you on Thursday.